I welcome you back. Now we have graphite. The other substance was graphite. Graphite is a covalent what? It is a covalent network. Below is structure. This is how it looks like. You see? I want to say that properties, the general ones which I'm going to give, properties of graphite, diamond, and silicon dioxide, the general ones which I'm going to give, okay, I'm going to emphasize them. They apply mainly these three substances: diamond, graphite, and sand. Diamond, graphite, and sand. These are the only at this level. Diamond, graphite, and sand at this level. Those three substances are the ones that have giant covalent structure. Remember that covalent bonding, earlier on I said that covalent bonding will give you two structures. It can give you the giant covalent structure and the simple molecular structure. The giant covalent structure is for solid substances. Like which ones? Diamond, graphite, and sand. Then for simple molecular structure, those are for gases and liquids. So the general properties I'm going to give, they can work on all these three substances. So you see, this is how the giant covalent structure looks like. You have atoms in black, which are linked together by covalent bonds, So allow me, having emphasized that, allow me share my response. So state, we start with the state. Graphite is a solid, exists as a solid at room temperature. Why? Have you seen that network? Within that network, we have strong covalent bonds that are compacted together. So because of presence of strong covalent bonds, it is a solid because of presence of strong covalent bonds between carbon atoms. Now, if it is diamond, still you say that exists as a solid at room temperature due to presence of strong covalent bonds between carbon atoms. Then if it is the sand is the silicon dioxide, you say that exists as a solid at room temperature due to presence of strong covalent bonds between silicon and oxygen atoms. As simple as that. Then solubility. Now, graphite is carbon. Carbon, think about charcoal. Graphite does not dissolve in water. Charcoal does not dissolve in water. So what are we going to say? It is insoluble in water and other polar solvents. Why? Water molecules cannot break apart its structure. They cannot break apart its structure. That's why it is insoluble in water. Then still, diamond is insoluble in water. Sand is insoluble in water because water molecules cannot break their structures. Then what is the type of structure here? It has a giant covalent structure. Giant covalent structure has what? The giant covalent structure has atoms joined together by covalent bonds. So here we are going to say that it has a giant covalent structure. Why? Because that structure is made up of carbon atoms which are held together by covalent bonds. If it is diamond, still diamond has a giant covalent structure in which carbon atoms are held together by covalent bonds. If it is sand, sand has a giant covalent structure in which silicon and oxygen atoms are held together by covalent bonds. Then melting point, sand is, it is very difficult to melt sand. Same thing applies to graphite. Same thing applies to diamond. Therefore, what are we going to say? That graphite has a high melting point and boiling point. The same point works for diamond. It is very easy. It is very difficult. It is very difficult to melt diamond. It is very difficult to melt sand. That's why we say that they have high melting and boiling points. Why? Still due to presence. It is very difficult to melt them because of what? You have stronger bonds that require much heat. These lines you are seeing here, colleagues, these lines, those lines, the covalent bonds, those lines, it is very them. Now in sand, you see, you are having silicon atoms bonded to atoms of oxygen. Sand is the same as silicon dioxide. those lines, it's very difficult to break them because they are strong covalent bonds. Then, which other one? Also, apart from melting, then there is also conduction. Graphite, by the way, graphite only is the only non-metal which conducts electricity. Why? Within the structure of graphite, you have mobile electrons. So it conducts electricity due to presence of delocalized electrons within its structure. Note that the first four properties exist as a solid, insoluble in water, giant covalent structure, high melting point. The first four, they can work for diamond, they can work for sand. This one here does not work for diamond and sand. So if you have diamond, you say that does not conduct electricity. If you have sand, you say that does not conduct electricity due to absence of delocalized electrons within its structure. Within its structure. So here graphite conducts due to presence of delocalized electrons within its structure. But the other two, they do not. I have said that for giant covalent colleagues, you always interact with graphite, diamond, sand. Graphite, diamond, sand. How do you memorize those properties? State, solubility, structure, melting point, conduction, density. Then also this other one here does not apply to the others. Now you see graphite has a low density due to its relatively open structure. Now this cannot work for sand. Sand has a higher density. That's why if you put it in water, it goes down. Yeah. But carbon, if you put charcoal on water, it will be up. It will be up. So that's why it has a low density. So the first four, they work for the others as well. However, there are also other properties of graphite which you can think about. They are here. Which other properties? Other points which one can think about apart from those ones? Graphite is soft and slippery. It's soft and slippery. Due to presence of these layers. Are you seeing the reason as to why it is soft? It is soft and slippery because are you seeing these layers of graphite? There is this layer up and this layer down. So those layers within its structure, those layers can slide over each other because you have weak intermolecular forces of attraction. So holding the layers, not holding atoms, holding the layers. The layers are joined by weak intermolecular forces of attraction. So that's why it is soft and slippery. Then also it is dark and opaque. Yeah, it's dark and opaque. So what am I left with? I think I'm only left with the one one substance, and that is what? That is methane gas. Allow me first stop here.